Let's go ahead and get started today. Our presenter is Tim Madden. Tim is the Senior CAM Engineer at Royal Circuit. He has been involved in the manufacturing and design of circuit boards for 25 years, working for a variety of companies. He's been with Royal Circuit for over 3 years, and I think his 4-year anniversary is in a couple months. So now I will go ahead and turn it over to Tim.
Thanks, Lisa. She said, my name is Tim. I've been in the industry for over 25 years, working for both manufacturing and the design departments for several different companies. So I do understand the problems for both sides when a job is put on hold. Over to the fab house, they're off working on another design of projects. Then when a job is put on hold or delayed for any reason, it affects both projects they're working on when they're pulled back to have to deal with questions from the fab house. In the perfect world, we like to think that we're all working together, but in reality, usually they're just throwing it over the wall. We want the boards built, assembled, and then back for production as quickly as possible. So the purpose of this is to avoid all the common reasons for a fab house putting a job on hold, and for you to get your boards as fast as possible and exactly how you expect it. We often see the expect delays sign for road constructions. This should never happen with your printed circuit board. Delays do happen, but they should never be expected. And with just a little preparation, all the major causes of a job going on hold can be avoided. Just like when you are working on a design and you think you have the greatest new part to use, only to discover too late that it will take 6 months for you to get it. You have to go back and revise the entire design that you've already finished. You want to avoid that, so you always do your research for parts up front. The same effort should be put into the board to make sure that your fab house can build it and you can provide them with all the information right away, and then that way there's no delays once you send it over to them to be actually manufactured. In my perfect world, this would happen. Board design takes 2 weeks. Yeah, right, I know. Goes to the board manufacturer for a week, goes to the assembly for a week, and voila, you got your wonderful, perfect design that's going to save the world. What's often the case is you spend a couple weeks in your board design, it goes to the board manufacturer for a day. They're missing something or have a question, it gets sent back to the board designer. They answer it, goes back to the board manufacturer, puts a little rush on it. Same thing with the assembly house. You still get it on time, but there's some slight cost overruns for the rush order. And here's often what I've discovered in the realities often happens is you spend a couple weeks on the design, goes to the board manufacturer for a day. They realize they're missing something. Meanwhile, the designer's been off on another project, can't get back to the question for the first one for a couple of days, finally gets back to the board house. They discover they're still missing some stuff. Another day is, in the meantime, the designer's tied up to deal with an old revised design, spends 2 days there, finally gets it back to the board manufacturer. They put a rush on it, get it done in 3 days. By that time, you've missed your scheduled time at the assembly house. They can't get to it for another week. Spends a week there, and you're 2 weeks late. And you have to explain to the project manager why it's almost 3 weeks behind schedule. And usually board design is not a critical path, and that's always the bad sign when on the Gantt chart it becomes red that your little board design has become the critical path for getting the new product out. So we want to avoid that. So there's a couple of reasons for a job going on hold, and it really all has to do with the data. There's bad data, missing data, and of course conflicting data. So in this day and age, it's all about the data. Can we get it right from the beginning? 25 years ago, bad data was probably the most common reason for questions or issues with jobs. Here we've got like cross traces, a dead end trace. You have bad solder mask where oversized pads are exposing traces all over the place or missing off of pads. You have shorts or opens on the board discovered from a netless check or just from the board house going through looking, does this look right? As I said, 25 years ago, this was probably the most common reason for putting a job on hold. In the meantime, board design software has improved dramatically. as well as I like to think the users of it as well have gotten better with it. So this actually is what we see very infrequently anymore, where there's actually bad or design issues from the designer. But what has taken place is we're missing data a lot more than we get used to. So what is needed for a manufacturer to build a board? Artwork files. This is an ancient term from back when we used to do tape layups and shooting the tape layups with cameras putting on film. So we still call it artwork, but that refers to the individual layers of the boards, the component side, the inner layers, silk screen, the solder mask. And this can either be in Gerber format or ODB++. Gerber format's been the industry standard forever. It's a simple ASCII file with one individual file for each layer of the board. ODB++ has gotten a little bit more popular in the last 15 years or so. I think originally developed by Valor, now Genesis. And that is a one individual database that has all the artwork files within it, as well as a lot of other design information. Can include the fab drawings, net lists, even schematics can all be contained within the ODB++. We can read those files in with our design software we use. We use Genesis here at Royal Circuits, and any Gerber viewer can read in an ODB++ file as well as individual Gerber data. We also need all the hole size and board dimensions information. Hole sizes can be found in drill files, and that's the ideal way it comes in, and the drill file is just the ASCII file with all the hole size locations as well as the size of the holes. And also it can be then the board dimensions can be found on the with the board outline on the individual artwork files as well. A fab drawing is also usually preferred, and this then is a more formally dimensioned drawing. You need fabrication notes, and that means just how you want the board built. Is the thickness 062, color of silk screen, the type of finish on the board, etc. The IPC net list is technically optional, but we strongly encourage it. This is a direct output from your design software, and it has to be in the IPC format. Almost all Gerber viewers can read these in anymore, and then we can run a compare against the IPC net list versus the Gerber files to make sure there's no conflicts. With Genesis, it's always being run even as we're preparing the board for manufacturer. So there's no way we can make a mistake by any chance by deleting a trace or a pad or shorting something out. It's always running a check against the original design. Conflicting data. This usually involves fabrication notes either with themselves or with the data or the purchase order. We get conflicting data with the Gerber files and the IPC net list where they say that there's a shorter open happens in there. Sometimes this is intentional, usually it's not. If we see a conflict with the Gerber files versus the IPC net list, we'll almost always question it. You have conflicts between fabrication notes versus the data. An example of this would be saying there's legend on top and bottom, and then there's only one legend provided in the artwork files. And then conflicts also with fabrication notes within themselves. You might have a note that says the board is to be 062 thick, and then you also provide a stack up showing layer to layer spacing, and when you add those up it comes up to being 070. Once again, this is usually a critical error or critical issue that we want to make sure we get it right, and so this could cause a question or delay. So fabrication notes, they can be something as simple as a simple text file that says build an 062 board, hassle finish with white silk screen. Or you can also get a wall of text of either on the fab print or pages on a individual company specifications on a file from there. You can do it as simple or as complex as you want. The more complex often leaves the less questions and later up there. But you also have to be sure that everything is correct. Fabrication notes are often reused between designs. I know I've done that plenty. It saves a lot of time, but can also lead to trouble or confusion, as the fabrication notes for one design or one project really don't apply to the new one. Standard first note is what specifications you fabricate to. If you don't have it, you can say something as simple as best practices, which then leaves a lot of room for error or interpretation from the board house. At Royal Circuits, we always build to IPC Class 2 at a minimum, but another board house might go, well, okay, so the hole is 10 thousandths bigger than you specified, but that's within our best common practices. So citing at least the current revision of the IPC one takes away any of those questions from there. Solid mask and silkscreen, the color and the number of sides. Once again, this could also be a lot of confusion as you use it from a design. You say you want double-sided silkscreen and then only really need the top side. So make sure that's correct. If vias are tinted, that's often called out on the notes, saying all vias tinted, but then you throw a couple of vias under the thermal pad on an IC used to pull away the heat, and obviously those are tinted. So we may question that to say, okay, is this correct or not? Because you have a conflict between your fabrication notes and the actual data. Usually these are fairly easy to figure out, and we try to be fairly flexible at Royal and say, okay, this is really what they want. We're not going to question something that's obviously that these vias are not supposed to be covered as they're within the underneath the IC. Probably the most common thing we're seeing these days is the fabrication note saying, check the IPC net list to the Gerber data. Once again, something we really encourage, but the DET file not getting that is really a common problem. Do we build a board without it, or spend a day questioning, okay, do we need this or not? So be sure if you call out for it on the notes, you've provided the ET file. And then for all design software, there's many different ways to do a net list. And so you want to make sure you do an IPC output. When you're designing your board, understanding the capabilities of the board shop will also save lots of time. Designing it so it is easy to manufacture could also save delays if the manufacturer has problems. The old keep it simple, stupid phrase always still works. So you want the design to be done as simple as possible, but still meet what you need. You want to look at the capabilities of the board shop. How many layers can they do? What materials are they used to using? Copper weights, hole sizes, the aspect ratio, the trace and width spacing. Any special processes that you might need. Can they do this routinely, or is it a challenge for them? Line and buried vias, filled vias, countersinking, milling. All these are the obvious questions that you want to raise with your board shops. We just launched a really nice new website this week, and it clearly lays out our capabilities. Here's a screenshot from that includes most of it. We've broken it down to what we call standard and advanced. Standard are stuff we can do all day long without a second thought. Advanced means, yes, we're very comfortable doing this, but we know that we'll probably have to charge a little bit more because we'll require a little bit more time, probably making a little bit bigger overage so you get your full order when you want it. And just because it's listed on here doesn't mean we can build it easily that way. The obvious example here is moon, trace, and space. We can do 4 and 4 all day long without a problem. You throw that on 3-ounce interlayer copper, then we've got an issue. So just because everything falls within the standard doesn't necessarily mean we can still meet it. And that's the question. Usually the trace and width spacing is one of the more difficult ones, and the copper weight can certainly affect that. And certainly just because we can say we can do 6 ounce inner copper, we can't do that on 4 mils, 4 and 4 at that point. IPC class 2 versus IP class 3. You always want to know the difference. IPC class 3 really only calls out for there's a lot more documentation and testing done. We still build the boards the same way. They still meet the standards of quality. Both class 3 will provide the additional paperwork and cross sections to show what we've done. Aspect ratio is another common one. 10:1 we can do no problem. So that's something to be aware of, that if you're throwing in some small vias, you don't want a 125 thick board, and then throw in 4 mil vias, finish size vias on there, as that will then be pushing the upper limits, and you run the risk of getting voids. You can look on our website to find this out. It's just, we revamped it. It's going live this week. It's even got more extensive listing than what I'm showing here, with all the different capabilities that we've got. And then the last thing I wanted to say about capabilities, forgot this earlier, is don't just plug these into your design parameters, especially for a lot of different design software. They'll say, what's the minimum trace, what's the space and trace you want to do. You throw that 4 and 4 in, and you've got a big power board. Suddenly it's just doing 4 mil traces and 4 mil spaces all next to each other, when you've got plenty of real estate and you can easily do 5 and 5. This goes back to what I was saying, is make it as simple on the board shop as possible, and you'll get your boards on time and with the fewest questions later. I know this is pretty basic for most of you stuff, but it really is one of those things to think about, that because it's so basic, everyone forgets about it, and then they want to, then that's when they get their boards late, or if there's any questions, that tying up the designer's time, that once they're done with it, done. I don't know if there's any questions or anything. You can type it in the chat, or if you want to get a hold of me later, feel free to email me or contact any of us at Royal Circuits, and we're glad to help you out, get you the boards you want, when you need them, as quickly as possible, and exactly how you want them.
All right, I'm looking at the chat box here, and does anybody have any questions that they would like to type in there? Let us know. Otherwise, I will be emailing a recording of this presentation to you. If you would like actual copies of the slides, you can go ahead and email Tim at royalcircuits.com, and I know he'd be happy to send them to you. All right. Well, thank you very much for everybody for attending, and we look forward to having a chance to work with you in the near future. Thank you, Tim.